Hi, I am Sanjay Patel. In this lecture, first of all, we are discussing an important problem about the intersection of a sphere and a plane, and then we'll be discussing intersection of two spheres. So let us start with that important example. So discuss the intersection of the sphere x square plus y square plus z square minus 2x plus 4y plus 4z minus 16 is equal to 0, and the plane 2x minus y plus 2z is equal to 12. Okay, so let us start this way. The solution to this problem. Here, for the sphere S, let me call the sphere S, is x square plus y square plus z square minus 2x plus 4y plus 4z minus 16 equal to 0. So the center of this sphere is C, that is minus u, minus v and minus w, is given by just divide the coefficients of x, y, z by 2 and change the sign. So here the coefficient of x is minus 2, so I am dividing it by 2 and then giving the opposite sign. So it is minus 1 and then plus 1. This is 4 by 2 is 2 and then changing the sign, so minus 2. Again 4 by 2 is 2, so again changing the sign, so minus 2. So this is the center. And the radius of the sphere, that is r, you know the formula for the general equation is u square plus v square plus w square minus d. Here what is d? In our question d is, this is minus 16. And UVW, u is equal to minus 1, v is equal to plus 2 and w is equal to plus 2. But since there is square, so there is no problem whether you write plus or minus. So this will give you 1 plus 4 minus 16. So this is equal to 8 plus 1, 9 plus 16, so it is 25. So square root of 25 is 5. So the radius of the sphere is 5. Now we are going to obtain the perpendicular distance. Here the equation of the plane is given by 2x minus y plus 2z is equal to 12. And I want to find the distance of the center of the sphere to this plane. So suppose we have a sphere like this, and the center is, we already found the center, which is 1 minus 2 minus 2, and suppose this is my plane, and the equation of this plane is 2x minus y plus 2z is equal to 12. I want to find this distance. So I am dropping a perpendicular from C onto this plane and I want to find CM. We have the formula for Cm. So Cm, as you know, it is a into x1 plus b into y1, as you know. So just without remembering that, just put 1 minus 2 in this equation. So like this. So 2 into x. X, you can put the value of this x coordinate of the center. Minus 1 into y. Y is minus 2. Plus 2 into z, which is minus 2. And minus d, the value of this constant, that is minus 12. Recall that I am using the formula to find the distance of a point outside of the plane, the perpendicular distance formula, upon square root of this 2 square, okay, minus 1 square plus 2 square. So this gives me, this is 2 plus 2 plus, it is minus 4. 2 plus 2 minus 4 and minus 12 upon square root of 4 plus 4, 8 plus 1, 9, square root of 9. So what will you get? Here is, this is equal to 2 plus 2, 4, 4 minus 4 is cancelled. So it is 12 mod of minus 12 upon square root of 9, that is 3. So finally, since it is distance, we will be taking the positive square root. So it is 3 4s are 12. So Cm is equal to 4. The perpendicular distance Cm, this distance is 4. Okay, and what is the radius? Radius of the sphere is 5. That was 5 we have found. So actually we have to redraw the figure because this Cm is smaller than 5. So the conclusion is, okay, so clearly Cm is less than the radius because Cm is 4 and the radius is 5. So the conclusion is S intersection pi is non-empty, rather it is a circle. Okay, so our situation will be like this. Say if I consider a sphere, okay, and this is the center of the sphere C, and we have a plane also. Let me take some, we have a plane. Just okay, let me remove this. Okay, I want to draw a plane which intersects this sphere. So let us move it like this. Okay, and this plane is intersecting the sphere. So the distance from this center to this plane, which is Cm, okay, and this is intersecting in a circle. So this is our circle of intersection. Okay, we want to find the radius also. In addition to this question, I am taking some more interesting question, that how to find the center and radius of this circle of intersection. We have the sphere S and the plane pi. Okay, so I want to find the radius. This is, let us call this point to be P, and if you join C and P, then this is the radius of the sphere, and we have already obtained the radius as 5. So this is 5, this is 5, and the length cm is 4. We know that cm is equal to 4 and the radius r of the sphere is 5, and cm is less than r, so the plane intersect the sphere. What was the equation of the plane? Let me write down over here. It was 2x minus y plus 2z is equal to 12. Okay, and the center of the sphere was 1 minus 2 minus 2. Okay, and this is the perpendicular. So to find the radius of the circle of intersection, that is the value of MP, I can say in the triangle, which is a right angle triangle, in the triangle CMP, we have CP square is equal to CM square plus MP square. What is CP? It is nothing but 5. So it is 5 square. CM is 4. So 4 square plus MP square. So we'll get MP square is equal to 25 minus 16 is equal to 9. So that gives me MP is equal to 3. So what is this MP? MP is this radius of the circle of intersection. Now I'm interested in finding the center M coordinates of the circle, which is intersection of the sphere and the plane. So to find the center, you can see that the line CM, if you think of the line CM, let me show you by some the line CM, which is passing through, yes, this line, let me extend first, and okay, it is passing through the center of the circle which we are interested in. So if I find the equation of line, which is I can see from the figure that it is easy to do that, and if I take the intersection of the line with the plane, which you already know from your higher secondary course, how to get intersection of intersection of a line in a plane, which is very simple. So first I will be finding the equation of the line L. You observe that this line L is nothing but the line passing through this perpendicular CM. So it is perpendicular to the plane pi also. And what is the vector which is perpendicular, always perpendicular to the given plane? So if this is the plane, and a vector which is always perpendicular is called normal of the plane. So normal is nothing but obtained by collecting the coefficients x, y, z and writing as a vector. So this is 2, minus 1 and 2 is the normal of this plane. Okay. You know that for the equation ax plus by plus cz is equal to d, this a, b and c values gives the direction of the normal, and this line L is perpendicular to the plane. So the direction of the line L is also same as the direction of this normal vector. Okay. So I'll be taking the direction of this line as 2, minus 1 and 2. Also you note that this line is passing through this center whose coordinates are also known to us, 1, minus 2 and minus 2. So it is clear that if you have a point in R3 and the direction of a line passing through that point, you can write down the equation of that line immediately. So let me write down. First of all, the equation of the line CM passing through the point C, which is 1 minus 2 minus 2, and having direction as n bar, which is we obtained as, what was that, direction 2 minus 1 2. Here it is, 2 minus 1 2. 2 minus 1 2 is given by x minus 1 upon 2. This is the point x1 y1 z1, and this is the direction L, M and N. L, M and N. So we'll get x minus 1 upon 2, y plus 2, y minus minus, x minus x1 upon L is equal to y minus y1 upon M is equal to z minus z1 upon N is the equation of a line in R3. So I can write y plus 2 upon minus 1, it is this M, then z plus 2 upon N, that is 2, and is equal to, say, k, where k belongs to R. Let me call this equation number 1. So this is my equation of line CM. What is the line CM? It is this line, line L is the line CM. So if I want to write down the coordinates of any arbitrary point on this line, okay, then I can do that by finding xyz from this equation. So comparing each of this ratio with k, I can get the value of xyz. So let me write down this way. The coordinates of any point on the line L or the line CM, both are same, is given by x minus 1 upon 2 is equal to k, gives you x is equal to 2k plus 1. Okay, then comparing y plus 2 with this k, we will get y is equal to minus k minus 2, and z is equal to 2k minus 2. So these are the coordinates of any arbitrary point on the line L, and this line is intersecting, as you know here, it is intersecting the plane. It is intersecting the plane at the point M, and we want to find the coordinates of the point M. So for some value of that k, this line will pass through the point M. So for some k, I can write like this: for some k belongs to R, this point, the point 2k plus 1 minus k minus 2, 2k minus 2, okay, this point lies on the plane pi. Okay, what is the equation of the plane? It was this 2x minus y minus plus 2z. So let me write the plane pi, that is 2x minus y plus 2z is equal to 12. So for some k, this point lies on this plane, so it will satisfy this equation. So what you will get is 2 into, this is your x, y and z, which you can substitute in this. So we'll get 2 into 2k plus 1, okay, minus 1 into minus k minus 2 plus 2 into z, which is 2k minus 2, is equal to 12. So if you simplify, you can get the value of k from this. Okay, so simplifying this, so 4k plus 2 plus k plus 2 plus 4k minus 4 is equal to 12. So 4k plus k, 5k plus 4k is 9k, and this 2 plus 2, 4, 4 minus 4, 0, so is equal to 12. So that gives me k is equal to 12 by 9, which is nothing but 4 by 3. So for this says, for this particular value of k, this line intersects the plane at the point M. So for this point, for this k, the coordinates of the point of intersection, so if I put k is equal to 4 by 3 in that in this point, which is 2k plus 1 minus k minus 2 and 2k minus 2, okay, because we have got this point, which is an arbitrary point on this line, and for some value of k, which is in particular 4 by 3, this point is on the plane. So what I will get is this is equal to 2 into 4 by 3 plus 1 minus 4 by 3 minus 2 and 2 into 4 by 3 minus 2. So we will be getting this, and if you simplify, what you will get is, say, 8 by 3 plus 1, so it is 11 by 3, and this is minus 6, so it is minus 10 by 3. This is 8 by 3 minus 2, so it is 8 minus 6. 8 minus 6, so it is 2 by 3. Yes. So this is nothing but the point capital M. So that is the center of the circle of intersection. It is the center of circle. So you obtain the center, and the radius was already obtained. The radius of the circle, which was I think it was 3. Yes. Yes, this radius is 3, and we have got the center coordinates. Okay. So radius, which we already obtained earlier, is 3. So these are our two required additional questions. So thank you.